Hi everybody, I am back again with my latest video on space physics, and in this one I want to cover the idea of the expanding universe, which obviously is the idea that the universe is not static, it's not stuck in place over time, it's actually getting larger. The interesting idea here is if we accept the idea that the universe is getting larger over time, if we could go back in time, we'd have to accept that the fact that years and years and years ago the universe was smaller. We go back even further in time, the universe was smaller than that. And if you go back far enough, what that means is there was a point in time where the universe couldn't be any smaller. And that would be a point before the universe was born, or before the universe started to expand. We'd call that point a singularity. And if we accept the idea of a singularity, that the whole universe existed in one point in space before it started to expand, we also have to accept the idea that the universe, or there was an event upon which the universe actually started to expand. And you probably already know this. We have a name for that event. It was originally coined as a joke by the great astronomer Fred Hoyle, and he called that point in time the Big Bang. He actually didn't believe that the Big Bang was possible, which is why he came up with this silly name. But over time, evidence has been collected by scientists. Basically, these two pieces of evidence we'll talk about today, redshift and CMBR. And that evidence tells us that the Big Bang actually did happen. There was a point where the universe started to expand. Okay, so we'll cover those two pieces of evidence now. The first one is here. We'll call it redshift. Okay, this takes some explaining, so I hope I can do it justice. Here we've got the Earth, or us, and we're observing the observable universe. And let's say we observe this star, this blue star, let's call it. Okay. Now you know obviously that when you observe stars, you're seeing light as it was when it left that star. In many cases, that could be billions of years ago. So let's imagine a case where the universe is static. So therefore, the distance between us, the Earth, and this star is stuck. It's not changing. And that means it might take time for the light to get to us, but these waves of light, let's just talk about visible light. It could be all the other types of light or electromagnetic radiation, but let's think about visible light. Let's say the blue light here, the blue visible light, leaves the star and it's got a certain wavelength. I'm doing a terrible job here, but let's say that wave, that transverse wave of light, leaves the star and eventually, after a long time, reaches the Earth. In a static universe, that light wouldn't have changed. We would see that light or that radiation or that electromagnetic radiation in exactly the same way as it was when it left that star. Right, let's imagine another case now where the universe is expanding. If the universe is expanding, then let's say this is the same star. I know it looks red, but let's say it's the blue star. That blue star is moving away from us. So therefore, the wavelength of the light will therefore be stretched. It will no longer be this wavelength, it will be a much longer wavelength. Let's represent it very badly like this. Okay, and that reaches us. Now in this case, the light that is leaving the star and reaching us is not the same. And the reason for that is the distance is increasing between us. And as the distance between the star and the Earth gets bigger, it stretches the light. It stretches the wavelength. So therefore the wavelength gets longer. And that's the reason why I've represented this star now as a red star. The light that left that star may have originally been blue, but when it reaches us, because it's been stretched to a longer wavelength is towards the red end of the spectrum rather than the blue end of the spectrum. And that's the reason we say this light has been red shifted. It's been shifted from the short wavelengths to the longer wavelengths. So therefore, technically speaking, we no longer see this blue star as blue. We see this blue star as red. because the light that reaches us has been stretched, or the wavelength has been stretched. And when you observe stars that are moving away from us, the further stars from us, we do actually see that these stars have been shifted to the red end of the spectrum, or I should say the light that is leaving those stars has been shifted to the red end of the spectrum. So I hope that made sense. That's the first piece of evidence for the expanding universe, and we call it redshift. Remember though, please, it's not just visible light. It would be all of the, it's easy to think about visible light, but it would be all of the radiation in the electromagnetic spectrum. If you need to refresh your memory about that, please go back to my video about the electromagnetic spectrum. Okay, hope that made sense. Second piece of evidence is called cosmic microwave background radiation. Here on the screen you can see the evidence that I've put together, but in a very basic level. If we accept that the Big Bang happened, we'd have to accept that an awful lot of radiation, or imaginably large amount of radiation, was expelled from that point all at the same time. That would have been the most energetic radiation, which would have been gamma rays. So if the Big Bang happened, we would expect all of this radiation to be all around us. But a second thing is, because we already have evidence that the universe is expanding, if the universe is expanding, that radiation would also have been stretched in wavelength. So therefore it wouldn't be short wavelength gamma radiation, it would be longer wavelength radiation, basically in the section of the electromagnetic spectrum of the microwaves. So we would expect to look out into the universe and be able to gather information of all of this microwave radiation that's all around us. And in 1964, that's exactly what happened. That radiation was discovered. It is all around us. And that's the best evidence we have, as well as redshift, for, first of all, the Big Bang, and secondly, for the expanding universe. Okay, that's about it. I hope it'll be quick. I think it is quick. So just to recap then, please, the universe is not static. We accept that it's expanding. If it is expanding, we would expect two pieces of evidence. One is that light is redshifted from short wavelength to long wavelength, and we see that around us all the time. And the second piece of evidence would be this idea that cosmic microwave background radiation is all around us, and that has now been discovered. It's without question. And on the back of that, what that also means is if we accept that the universe is expanding, we also accept the idea that it started at a singularity. And it started at a singularity with this idea of a point in time when the universe started to expand, and we call that point the Big Bang. Okay, hope I explained it okay. If not, please get back to me as usual. Thank you very much, everybody, and I will see you soon. Take care.